Hello students, today's agenda is to check homework. We'll be working with chords, secants, and tangent measurements. And today you will be able to work on 9.5. Today students will be able to find measurements of chords, secants, and tangents. And actually it's segments of them, okay? Before we can start, let me give you some information. So just to recall from previous lessons, when a line goes from one side to the other of a circle but does not cross on the center, that's called a chord, okay? And when two chords intersect, we can say that A times B equals D times C. What does that mean? That A times B are on the same chord. There are two different segments of the same chord, and when you multiply them, that's equals to the multiplication of the other two segments of the other chord, okay? So that is gonna look a lot easier once we start the practice. Okay, also in here we have these two lines that go outside. Well, they have a section inside of the circle and then it goes outside and they meet outside. Okay, pretend that this is not there. One is a little longer. Those are called secants. Okay, and the rule when two secants meet is that x plus y, okay, the addition of that multiplied by the section outside, meaning y, is going to be equal to w plus z multiplied by the outside section, okay? So you add them and then you multiply by the piece that is outside. Again, it's gonna look a lot easier once we start the practice or we put it into like with real numbers. In here we have a secant and we have a tangent line. So when we have something like that, for the secant you do the same thing. You add the two segments and multiply by the little piece outside, and that's going to be equal to the tangent square. And somebody asked me, teacher, why is that? And I said, well, it's the same thing. The only thing is that when we're adding the section inside, we don't have anything inside, so we have 0 plus the section outside, right? Like inside plus outside, which is t, multiply times the section outside, which is t. Notice how for this part, if we do distributive property, we get 0 times t is 0t plus t times t is t squared. And 0 times t is just 0, so basically we end up with t squared. That's why, I mean, it keeps the same rule, but again, you don't need to really focus on this if you don't want to. So let's put this into practice. We're going to start with a couple of these ones. And so, it says find the value of x. So again, for chords, what we're gonna do is multiply the two pieces of the chord. So 5 times 4 equals x times 2. Now, it doesn't matter if you put 2 times x or 4 times 5. It doesn't matter as long as you multiply within the same segment, okay? So 5 times 4 is 20. Equals 2 times x, x times 2 is 2x. If we're multiplying, the opposite of multiplication is division. And so x equals 10. Okay, so that's going to be the value of x in here. And if you want to check, 5 times 4 is 20 and 10 times 2 is also 20. So yes, it does make sense. Okay, same thing for this one. You're going to find the value of x. And so we have 4 times x equals 2 times 10 4 times x. Oh, notice how in here I put a dot, in here I put parentheses. Same thing. You can put parentheses here, or you can put a dot in here. So 4 times x is 4x. 2 times 10 is 20. If I'm multiplying, the opposite of multiplication is division. And so x equals 5. Okay, again, 2 times 10 is 20. 4 times 5 is 20. So check. Okay, let's look at this one. Again, multiply within each chord. So we have x times 4x, right? We multiply those, equals 8 times 8. And x times 4x is 4x squared. Okay, because x times x, just like we add the exponents. And 8 times 8 is 64. We cannot solve for x yet because we're multiplying by 4. The opposite of multiplication is division. And so now I have x squared is equals to 64 divided by 4 is 16. In here, you're going to use your calculator. And I'm going to have to go get it right now. But try it. What would be the square root of... The square cancels with the square root. And since I do it on one side, I have to do it on the other to keep the balance. And so x equals 4. If you replace 4 in here, this is equals to 4. In here, 4 times 4 is equals to 16. And 4 times 16 is 64. 8 times 8 is 64. So check. Okay, try this one. I'm going to go get my calculator in the meantime because we're going to be needing that later on. Okay, did you try it? Okay, so we have 6 times x is 6x. And then we have 5 times x plus 2. Since it's 2 terms, we're going to have to put that between parentheses. We do distributive property, and so we get 6x equals 5x. 5 times 2 is 10. Don't forget to multiply by the second term. We subtract 5x from both sides. And so 6x minus 5x equals x. Some people put a 1 in there. You don't need to. And so x equals 10. Again, if you want to check again, in here you have 12. In here you have 10. 6 times 10 is 60. 5 times 12 is also 60. So you can see that it's the right process, that it's the right answer. Now let's look at the secant tangent example. Again, if you recall, we're going to be using, since it's a tangent and a secant, we're going to be using this last one where you add the two pieces times the piece outside. Add them first, times this piece outside equals the tangent square. Okay, so you add the pieces of the secant, multiply by the piece outside, and that's going to be equal to the tangent, which is labeled z square. Okay, always when it's a tangent, when we don't have a little piece inside of, or a piece of the line inside of the circle, that's when you square that. Okay, so some people do distributive property first and then start simplifying. Other people do PEMDAS. You add this first, and I think I want to show it both ways just because I know that some people are more used to the distributive property now. So let me do the distributive property. 6 times 14 is 84. 6 times 6 is 36. That's equals to z squared. In here, that's 10 carry 1, that's 12. So 120 is equals to c squared. Take the square root of both sides to cancel and leave z by itself. And so that's when we're gonna need, because this is not a perfect square, the next number that is a perfect square is 121. So we're gonna put it in our calculator. Sometimes you press the number first and then the square root, and that's gonna give you the answer. For some calculators, first you press the square root and then the number and then equal, okay? So it might be different in yours. Try whichever works. So in here, I'm gonna round it to the nearest hundredths, which is 10.95. Okay, let me show you if I do PEMDAS instead of distributive property. So we already said that we add this and multiply by the section outside equals the tangent square. And so if I do distributive property, parenthesis comes first, PEMDAS. Parenthesis come first, so 14 plus 6 is 20. Then exponent, but we don't have any exponents that we can simplify. This one cannot be simplified until the end because we're solving for that. Then multiplication and division, whichever comes first. And so we have multiplication, 6 times 20 is 120 equals c squared. And finally, we're just canceling, so we're not simplifying. And so these cancel each other, so z is equals to, we already did that in the calculator, and so it's 10.95. Okay. Okay, let's go to do one with 2 secants. And so again, for the 2 secants, you add and multiply times this. Add and multiply times the section outside. So it's gonna be 7 plus 5 times the section outside equals y times 6. This is a y, believe it or not. So it's 6 plus y or y plus 6, it doesn't matter. Times the piece outside, which is 6. And in here you can do PEMDAS or you can use distributive property. It's up to you. I'm gonna use just distributive property. I'm not gonna do it both ways. And in here you cannot do PEMDAS. It has to be distributive property because you have a variable in here. So 5 times 7 is 35. 5 times 5 is 25. And the other side is 6 times 6 is 36. 6 times y is 6y. If I'm adding 36, first let me simplify this. 35 plus 25 is 60. I just bring this side down the same way. So now I can say that where I'm adding, I'm going to subtract to cancel it. And so 6y is equals to, I know it's 24, but let me show you. If you have to borrow, just borrow, and this stays as 5. 10 minus 6 is 4. 5 minus 3 is 2. Finally, to leave y by itself, if I'm multiplying, the opposite is to divide. And so y is equals to 4. Okay, so the value of y is 4. Okay, let me do one last one. And so in here, you also have 2 secants, but now we have decimals, which is okay. We love decimals, we love fractions. So it's 5.5 plus 7.7 times 7.7 equal, remember we're adding those two and then multiplying the addition by whatever is outside. The other one is x plus 8 times whatever is outside, which is 8. In here, I think I want to do distributive property on one side and PEMDAS on the other. So I'm going to add first, and the answer, I'm going to multiply by that. So if I add this, I'm just going to bring down this 7.7. If I add this, it's going to be 7 plus 5 is 12, carry 1. And then 7 plus 5 is 12, and 1 is 13. Okay, and since the decimal point is in the second place, you just bring it down right there. I mean, not in the second place, right before the 10th. And here I'm doing distributive property because you have a variable you cannot add these two first, okay? So 8 times x is 8x. 8 times 8 is 64. In here, you can either do the long multiplication on the side, and I'm going to do it with the calculator first. I'm going to show you in a minute because this is the last example, but 13.2 times 7.7 equals 101.64. 101.64 equals 8x plus 64. I subtract 64 from both sides, and so I get 8x equals, you can do it with a calculator, minus 64 is 37.64, or you can just put zeros in here. 4 minus 0 is 4, 6 minus 0 is 6. I borrow from the 10 becomes 9, and this becomes 11. 11 minus 4 is 7. 9 minus 6 is 3. So that's the 37.64. Finally, I divide by 8. And so x is equals to, divided by 8 equals 4.7. I'm just going to leave it at 7. I'm going to round to the tenths. So why do I try to show you like in here that I subtracted and borrowed and things like that? Because you're going to be taking the placement test in college, and so it's good practice. What was I going to show you? I think I can do this. So if you don't want to see how to multiply decimals or how to divide decimals, you can just stop the video and have fun with 9.5. But here we go. 13.2, 7.7. Multiplying it by hand. 7 times 2 is 14, carry 1. 7 times 3 is 21, and 1 is 22, carry 2. 7 times 1 is 7, 8, 9. You're going to get this, since it's the same digit, you're going to get the same numbers. So remember that this is one place to the left, so that's why you start here. So the 4 goes here, the 2 goes here, and the 8 goes here. So again, it's because it's the same digit, okay? 7 times 2 is 14, but you don't put it here, but here. Then I add 4, 6, 0, carry 1, 9. I count how many decimals after, how many place values after the decimals, and so it's 1, 2. So I'm going to go back 1, 2, right there. Why did I get 90? 13.2 times 7.7. 14, carry 1. 3 times 7 is 21, carry 2. 7 times 1 is 7, 8, 9. 9. Oh my goodness. Yeah, great. I'm teaching you. So this is going to be 9. Okay, now let's add correctly. 4, 6, 9, 10, 11. There you go. And then carry 1, 9, 10. Now that's the 101.64. Okay. In division, you were supposed to divide 37.64 by 8. How many times does the 8 go into 37? Goes 4, because 4 times 8 is 32. You subtract and you get 5 and 0. You bring up this decimal point and bring down the 6. How many times does the 8 go into 56? It goes 7. 7 times 8 is 56. 0. You bring down the 4. How many times does the A go into 4? 0, and that's enough for you to round to the 10th. Okay, so goodbye, and sorry about that. I don't know how to, I did say 9, but I didn't write it. I don't know what happened. So have fun.